This video speaks of elevators within a building. The fact is, if elevators did not exist, many low-rise buildings and all high-rise buildings would not be viable. A low-rise building is defined as one less than 35 meters, 156 foot high, and no more than 8 stories. A high-rise building is defined as one greater than 35 meters high and more than 8 stories high. Today, the most familiar design of elevators is known as roped, whereas the elevator car is lowered and raised by use of what is known in the industry as traction steel ropes or cables, which operate from above. In the older hydraulic-powered elevator system, the car was pushed from below. Today, there will be an elevator machine room located above the elevator shaft, which will contain the motor, sheave, and all necessary controls. In the roped system, the cables are attached to the car and around a sheave located in the upper elevator mechanical room. As electric motors cause the sheave pulley to rotate, the elevator cables lift or lower the car as commanded. The sheave will be rotated in one direction to lift the car and rotated in the opposite direction to lower the car. The electric motor may be attached directly to the sheave, and this is referred to as a gearless elevator. When the electric motor is attached to a gear train that causes the sheave to move, this is referred as a geared elevator. Operation. The cables that are connected to the car are also connected to a counterweight, which is located hanging on the side of the sheave. The design is that counterweight will weigh equal to a 40% elevator car capacity, which provides the balanced system when the elevator car is 40% full. This is an energy-saving design, as equal loads on either side of the sheave require minimal energy to move the elevator car. This is simply making use of the potential energy of the elevator car, transferred to the counterweight as the car descends. The opposite effect occurs as the car ascends. It is indeed an energy-conserving design. There are guide rails located on the sides of the elevator shaft, along which the car and the counterweight travel, which keep both car and counterweight stable. These rails are also an integral part of the elevator car emergency stop system. Electric elevator safety. There is very little or virtually no chance of an elevator car dropping in an uncontrolled manner to the bottom. The steel cables are very strong and are designed in a redundant manner, as one cable can support both the counterweight and the elevator car. Elevators are built with 4 to 8 cables, so that breaking of one is not dangerous. As an added safety, the elevator cars are equipped with rail brakes, which will stop the car, and these brakes are activated if an increased elevator speed is sensed. The equipment which senses elevator speed is known as a governor, which is attached to the sheave and to the elevator car. If any elevator car speed increases over the norm is detected, the brakes are activated and the car is stopped. Another independent safety is elevator car and electromagnetic brakes that are kept open while there is power to the elevator system. If power is lost, the electromagnetic brakes activate and bring the elevator to a stop. There are also upper and lower automatic braking systems located in the shaft. If the car moves too far near the top or bottom of the shaft, the elevator will stop. The final safety system, which exists but is never expected to be used, is the shock absorber system. At the bottom of the shaft is a piston mounted in an oil filled cylinder, which works to remove whatever kinetic energy that exists from a falling elevator. Thank you so very much. Bye now.